Welcome all. So today we will discuss direct form 1, realization for IIR systems. So in the data filter structure determined directly from either equation 6 or from equation 1 is known as direct form 1 realization. So in this structure is obtained by cascading the structures for H1Z and H2Z. So first let us get the direct form structure for H1Z. So direct form 1 is obtained by cascading the structures for H1Z and H2Z, that is all zero system and all pole systems. So first we will calculate the direct form structure for H1Z. So direct form 1 structure for H1Z will be get by H1Z equal to summation over k equal to 0 to m bk z raised to minus k. So this is the equation for all zero systems. So here equation number, I will write the equation number in continuous order, so that will be equation 10. Okay, so what we know, Hz equal to y of z divided by x of z. So y of z is the output of the structure, output divided by input. Okay, so from this equation we can write H1Z equal to Wz divided by x of z. So here W of z is the output of the first structure. So xz is the input and the transfer function is H1z, and we will get the output Wz. Okay, so Wz is the output of the first stage. Okay, so using equation 10 we can write Wz equal to x of z, which will be equal to summation over k equal to 0 m b raised to k z raised to minus k will be equal to, so I will give the values for k. So first value will be b0 into z0 plus b1 z raised to minus 1 plus b2 z raised to minus 2, b2 z raised to minus 2 plus etc. up to m. Okay, so bm z raised to minus m. Okay, so this is the value we will get, and since z0 equal to 0, z raised to 0 will be equal to 1, we can write this equation as wz equal to, and x of z will be given to this side, so the equation will be b0 into x of z plus b1 z raised to minus 1 x of z plus b2 z raised to minus 2 x of z plus etc. bm z raised to m x of z. Okay, so this is equation number 11. So now we will take the inverse is the transform of equation 11. So we will get, so taking inverse is a transform of equation 11, then WSX inverse is a transform will be W of n, which will be equal to, b0 is a constant, so we will write b0 itself. X of z inverse is a transform will be x of n plus b1 is a constant, z raised to minus 1 x of z, so we will write the inverse is a transform will be x of n minus 1 plus b2 constant, z raised to minus 2 x of z will be x of n minus 2 plus etc. we will write plus bm constant, z raised to minus some x of z will be x of n minus m. Okay, this is equation number 12. So we will get the inverse as a transform of equation 11, that is the output of the first stage W of n will be equal to b0 x of n plus b1 x of n minus 1 b2 x of n minus 2. So this is the equation where b0 and b0, b1, b2 etc. bm are the coefficients. Okay, so now we will express this in the all zero system in the direct form and realization, first part into the diagrammatic form. So I will show in the picture in the downward. So we will get the equation as x of n equal to, omega n equal to b0 x of n b1 x of n minus 1. So you can see here x of n minus 1 x of n minus 2 x of n minus 1, all these values are inputs. This one present input and all these values are past inputs. Okay, so b0 b1 b2 bm etc. are the coefficients, and after adding these values we will get the omega 1 n as the first output. Okay, so the diagrammatic representation will be like this: x of n, so x of n into b0, that will be the first part, b0 into x of n, so that is shown here, b0 into x of n. Okay, So diagrammatically it is represented like this, b0 into x of n. So we will get omega n, to change this here. So omega n, so I will write the equation here, omega n, the first one is the b0 into x of n, okay, plus next one will be plus b1, next coefficient is b1, okay, so b1 into, b1 is a constant, so we will put like this, so b1 into xn minus 1, that is the next term, xn minus 1. So we will get the xn minus 1 by giving some delay to x of n. Okay, so it will be so giving delay to x of n, b1 into x of n minus 1. So x of n is a raised to minus 1 will be x of n minus 1 into b1. We will then it added to first value, we will get the w of n. Okay, next value will get by b2 into again delay to the x of n. So here we will see two delays will come. So b2 into z raised to minus 2 x of n. X of n is z raised to minus 2. 2 delay ആണ് ഇവിടെ കൊടുക്കുന്നത്. So it will be x of n minus 2. Okay, and the next value it will increase like this, and the next value will come, the last value I will write bm, then x of n minus m. Okay, so this is the last value. All this value add together, we will get the output of the first stage, that is omega n. Okay, so direct form realization of H1 as it is diagrammatically expressed by like this. Okay, so next we will see the direct form realization of the second stage, that is H2Z. So next part is direct form structure for H2Z. So we know H2Z equal to 1 divided by 1 plus summation k equal to 1 to n a k z raised to minus k. Okay, so H2Z will be right in the terms of output and input. We will write it as y of z divided by y of z is the output, and the input will be what we obtained from the first stage output, that will be omega z. Okay, so we will write y of z by omega z will be 1 divided by 1 plus summation k equal to 1 n a k z raised to minus k. Okay, so just cross multiply this equation. We will write it as y of z plus y of z summation over k equal to 1 to n a k z raised to minus k. This will be written in bracket and will be equal to wz. Okay, or we can write it as y of z, I will take these terms to right hand side, so minus summation number k equal to 1 to n ak z raised to minus k, and will be equal to plus y of z plus w of z. So expanding the summation, we can write it as y of z equal to minus a1 z raised to minus 1 y of z, we'll write it after next step. Okay, so plus a2 z raised to minus 2, a3 z raised to minus 3 plus etc. an z raised to minus n z raised to minus n y of z plus w of z. So I will take this y of z inside this bracket. So the next step will be y of z will be equal to minus a1 z raised to minus 1 y of z minus a2 z raised to minus 2 y of z minus an z raised to minus n y of z plus w z. So this is equation number, so it's the last equation number we written, so 12, and this one will be 13, and this one equation 14. Okay, so now I will take the inverse as a transform of this equation, taking inverse is a transform of equation 14. We will write y of n equal to minus a1 y of n minus 1 minus a2 y of n minus 2 minus a n y of n minus n plus w n. So this is equation number 15. So we get the inverse as a transform of second output stage. Okay, so where a1, a2, a3, etc. an are the coefficients. So here y of n minus, y of n minus 2, y of n minus are the delayed output times. So the output stage of this function direct form 2 will depends on the delayed outputs also. Okay, so now we will represent the direct form implementation of equation 15. Direct form implementation equation 15 is shown in figure. So this is the direct form 1 implementation of equation 16. Equation 15. So you can see omega n is the output of the first input state, so that we will given here, and the y of n is the output of the second stage, H2 is at stage. So you can see from the equation, this first term will be minus a1 y of n minus 1. Okay, so you can see here the output minus a1 y of n minus 1. So for omega n y of n will be equal to omega n plus one time delayed y of n, one time delayed, that is y of n minus 1 into minus a1 will be added to omega n. Okay, so that will be given here. Here there is no coefficient, this is just shown like maybe no need to draw this one. Okay, so just to draw directly, so y of n will be equal to omega n, that will be the first value, plus y of n equal to omega n plus the delayed one, that will be minus a1 y of n minus 1. Okay, again plus adding to the another coefficient minus a2 y of n minus 2, that is the second term, and it will go up to a raised to n. Okay, plus minus a n y of n minus n. Okay, so this is y of n. So direct form realization of H2S is already given here, that is this shown in this picture. So now what we going to do in direct form structure, we will cascade these two values. Okay, so we will cascading to get obtaining the direct form 1 structure. Direct form 1 structure will obtained by direct form 1 realization structure will obtained by cascading structure obtained by cascading H1Z and H2Z. Okay, so we will keep, this is figure 1, this one is the figure 1. Okay, figure 1, and this one figure 2. Okay, this is figure 2. So what we going to do is, we will cascading these two figures, or we will combining these two figures. So the direct form 1 structure or realization of IAR system is obtained by connecting figure 1 and 2. Okay, H1Z or H2Z, or by connecting figure 1 and 2. Okay, so we will get x of n or x of z. Okay, this will be Okay, now x of n or x of z. X of n is the input, will give to first transfer function h1 z, which will, and we will get the output of the first function is the omega w of z will be divided by x of z, or x of n is the input sent to the first transfer function h1 z, and we will get the output as omega w of n, and which is given to the input of the second stage or second transfer function, that is h2 z, okay, which is equal to y of z divided by w of z, and we will get the output as y of n or y of z. Okay, so we will get the direct form 1 structure by cascading the two figures. Okay, so h of z equal to h1 z into h2 z. So in the below figure we will cascading these two figures, and we will get it as, we will get it like this. Okay, the first figure shows the all zero system, that is direct form structure of h1 z, and this represents the direct form structure of h1 z. Okay, and here whole pole system, in this will represent the direct form structure of h2 z. Okay, we will combine these two figures and we will get the output of y of n. Okay, so just combine these two pictures and we will get the direct form 1 structure of IR filters. Now we will discuss the computational complexity of the direct form 1. Computational complexity of direct form 1 structures. So first one is the number of multiplications. Number of multiplications, that will be equal to m plus n plus 1. The second point is the number of additions in the systems. So that will be m minus n times. Okay, and the third point is number of memory locations needed. So this is the important factor, number of memory locations needed. Number of memory locations needed is equal to m plus n plus 1. Okay, this much is about direct form 1 realization of IR filters.